Hey guys, I hope you're doing great today. This is our chapter number 42 in which we are going to create our own cluster. That cluster will have one master node and one worker node. It depends on you if you can join more. If you have more worker nodes, you can join with the master node. But for this lab, since I have resources on my AWS, so if you can join one worker node, it would be the same practice to have more worker nodes joining your master node. So let's get started and make sure that you have subscribed DevOps Molvi. This is my Kubernetes by DevOps Molvi repository. I will share the link of this GitHub repository in the description of the video so that you can fork it and you must give it a star. So everything related to Kubernetes we are going to discuss in our lectures. I will share every information, every notes of the discussion in my YouTube tutorials on this GitHub repository. So I have opened the main the repositories page, and you can see I have this how to install Minikube. We have already did this and we practically installed Minikube on our virtual machine, Linux virtual machine. And also guys, if I click on what is Kubernetes, this is actually the main page of this repository, just like we have readme. So this is the readme of my repository, Kubernetes repository, and I have been sharing all the links of YouTube tutorials here and also the Google Docs, since two of these lectures had the slides on Google Docs, Google Slides. So I have also shared the URLs, links of those drives, those slides here, and a general information about Kubernetes and its components that we have already discussed in our previous lecture. So in our today's lecture, we are going to learn how to create a Kubernetes cluster. Okay, we can have Minikube on our local Linux virtual machine, and we can practice everything on that local Minikube cluster. But what if I'm asked to configure to create a cluster with one master node and two worker nodes, or one master node or three worker nodes? So we also know the process, the procedure to create a Kubernetes cluster that is actually for production environments. In a production environment, you know that there can be three master nodes and there can be 2 or 12, a dozen worker nodes for load balancing and for fault tolerance and also for high availability. And for this lecture guys, you can do it on your virtual machines as well. If you have 3 or 4 virtual machines, you can do it as well. But since I have virtual machines created on my AWS account, I have created a master node and a worker node on AWS EC2 instances. So I am going to configure, I'm going to create a Kubernetes cluster where I have one master node and one worker node. So it is one of my favorite guide in which we are going to create a Kubernetes cluster ourselves on a couple of virtual machines on our AWS account. I will show you that. And in this Kubernetes cluster, we will have one master node, and also I have shared the specs, at least 8 GB RAM and 2 CPUs, and one worker node with 4 GB RAM and 1 CPU each. So it means that if you want to have 3 or 4 worker nodes, you can create these worker nodes, you can create these virtual machines on your AWS account with these specs. Okay, and it is up to you. I have also written each and everything so that it should be easy for you. And if you want to have one master node and one worker nodes, you can create with these specs. In the beginning, I will have one master node and one worker node, and we will learn how we can join the worker node with the master node. If you can join one worker node it would be definitely easy for you to join 2, 3, or 4, or 12 worker nodes. The same practice should be observed on each new worker node. You just have to create worker node. You just have to create virtual machine on your AWS account, and you can do the same practice to add as many as worker nodes that you want. So now guys, the step number 1 is to create a VPC on AWS, and we need to have a virtual private cloud where we will run all our virtual machines. And if you don't want to create a VPC, you can use the default virtual private cloud of your AWS account, but I have created mine, and I will create a security group. I have did that, and let me show you that this is my console. So you can see I have VPC here. Now if I click on VPCs, you can see that I have created my own DevOps Molvi virtual private cloud with internet access, and I also have created a subnet, DevOps Molvi subnet, and an internet gateway to route and to connect the virtual machines with internet gateway. After that guys, I have created the EC2 machines, 2 virtual machines. One is my master node and the other is my worker node. Now you can see both machines are running. This is master node and it is a T3 large instance, and this is my worker node and it is T3 medium. This is 8 GB and this is 4 GB RAM, and these master node and worker nodes machines are created in the same VPC, in the same subnet, so that the communication, there shouldn't be any issues with the communication between master and worker nodes. That's why it is recommended to have your own VPC, to have your own virtual private cloud and subnets and security groups and the internet gateway within a virtual private cloud. So this is a recommended practice, but if you know AWS, you can do as per your choice. Now I have, this is my worker node, this is my master node, and I have this as my worker node. So after that, we have created the EC2 virtual machines, okay, and the VMs must be created in the same VPC that we created above and the same security groups. Now guys, the actual drill begins, and we will have to install containered on the master node, and we will do the same thing on our worker node, okay, because the components that are installed on the master node should be installed on the worker node, okay. There would be slight difference, and what is that difference I will tell you by the end of this video. So first of all, we have to install containered on the master node, and then we will install containered on the worker node. Guys, if you remember, we used Docker as our container runtime on Minikube, but for production systems, for large workloads, it is recommended to use containered instead of Docker. And the recent latest versions of Kubernetes are more comfortable, I would say, or more compatible with containered instead of Docker. So that's why we are going to install containered on our master and worker nodes. And containered is the container runtime, just like we have Docker or Podman. And guys, you know that the pod is the smallest unit in a Kubernetes cluster, and it contains containers, okay. Each pod contains containers, and those containers are created using a container runtime, just like Podman, Docker, containered, okay. And we are going to proceed with the installation of containered. Now there is a really important concept that we must know about swap memory, okay. Why should we disable swap memory? All the installation guides you see on the internet, on Google, they recommend to turn off, to disable swap memory. And why? What is the reason? I have also shared the reason with you guys, because disabling swap memory is that Kubernetes relies on a predictable memory usage for scheduling pods efficiently, and swap can make it difficult to accurately calculate the memory requirements of a pod. Therefore, it is recommended to disable to the swap memory to avoid any performance degradation issues. Guys, swap memory is just an additional virtual memory, and the swap memory is used to avoid our Linux servers to run out of memory. So swap is actually a virtual memory, but in Kubernetes we need actual physical memory. We need the actual RAM that our master node or worker nodes have. Therefore, it is recommended that we must disable the swap memory so that our Kubernetes cluster should have a clear idea that that much amount of memory or RAM I have on my master node or on my worker nodes. I hope that you got the concept. We disable the swap memory so that our Kubernetes cluster should not get confused with the memory allocation. It should have a clear idea of the exact physical memory on the master node or on the worker nodes, right? So if we disable swap, we will definitely have the actual physical memory. We will not have any virtual memory or any additional. We must disable swap, and this is one of the important interview questions and answers regarding Kubernetes. So that's why we disable swap. I hope that it is clear, and this command is used to disable swap. So I am logged in on my master node and I will run it using the root user. If you are using any other user, you have to run all these commands with sudo. I am using root, so because I feel more comfortable using the root user. And we are going to copy and paste all these commands that are here in this tutorial. After that, we need to run these following commands to install container. So the first step is to install containered. So I will apt update or apt get update, whatever, and apt install. Guys, this is a brand new virtual machine. This is a brand new master node, and I literally didn't execute any command before starting this lecture. And the purpose of doing so is that you have a clear picture when you start creating your own Kubernetes cluster. You can do it along with me, and you have to run all these commands. By the way, there is one point. It is Ubuntu 24.04. The operating system that I have is Ubuntu 24.04, and also I have to change the settings. Colors, I will use the system colors, and appearance I will change it to 14 so that you can clearly see. Apply. Now I think it is better. So I have run apt install. I will clear the screen, and the next command is to make this directory, and I will just copy and paste the command. This directory should be created, and after that I will download this GPG key for Docker, and it should work like a charm. And these commands can be run without any issues. And if you are okay, after that I will run apt get update, and my repository should be updated. So now this is actually the command to run to install containered. Okay, I will just run it containered.io, and it will install containered on my Ubuntu master node. And after that we are going to create a directory. So container has been installed. Now I will run this command and it will actually copy the default contents of our container configuration in this file known as config.toml. Okay, TOML. And I will just copy it, and you will see that our this file should be created. I can cat this file to see the contents. All right. Okay, now you can see we have this container config.toml. So it is actually the configuration file of container. And now I will run this command and I will edit config.toml, and I will set the value of system DC group is equal to true, which is false by default. And the purpose of setting this value is equal to true is that in the config.toml file, container is to enable the use of systemd for managing control groups for containers. That is the purpose of doing so. And I will edit this file and run it. Now I can find this. So I will copy and Control W, enter, and you can see it is false by default. So we have to create container groups, and that is why we need to make it true. And yes, whatever lecture you are following for installation Kubernetes cluster, you will find it. All right, and it is recommended. After that, we just have to restart container, and I will do so. And after that, systemctl status container, and it is active and running. So our container has been installed, and this is our container runtime to create containers in the pods on our worker nodes. The container should be installed now, and now we have to install Kubernetes components like Kubeadm. Kubeadm is just like Kubernetes Administrator. Kubelet, a service which communicates with the core components of the master node and also with the worker nodes. And we have Kubernetes CLI. So these three components should be installed on the master node and also on the worker nodes. So the first step is to get the GPG key. Okay, and now we are going to install our Kubernetes components on the master node. I will get the Kubernetes apt keyring.gpg key, and after that I will update the Kubernetes repository. Kubernetes, you can see every repository that we update should be here in etc apt. All right, and after that I will update, and I will just run this command to install these three components. First of all, I have to update apt update, and all right, it is done. And after that we are going to install the three major components of the master node, and it shouldn't take that much time, and we are going to have it in a couple of moments. All right, it is done. And now I will hold, or I will lock the versions. Okay, this command is used to lock the versions, and you can see the versions of these three components have been logged. So these are just some modules and dependencies, or you can see prerequisites that we have to install or add. And after that I will run this, and finally I will initialize after updating these configurations. And now I will start my master node, and running the Kubeadm init command, and it will initialize my Kubernetes cluster on this network. So I will just run, and let's see. I'm a little nervous. I would like to see that this command should work perfectly without any issues. So let's see how it goes. Okay, now it is pulling the images required for setting up a Kubernetes cluster, right? And it is using this command to pull the images. And now I hope that you're following up with me running this command. And now you can see etc Kubernetes. All right, our Kubernetes Kubernetes cluster has been initialized, and now there are some important points that we must know. Your Kubernetes control plane has initialized successfully, and control plane is master node. All right, control plane is master node. So our control plane, or I can say all the components of the master node, has been initialized. To start using your cluster, you need to run the following as a regular user. First of all, I will create this directory. So we have to run these commands so that we can access our cluster without any issues. Every configuration regarding our cluster is stored here, and we want that we can access every data, users, contacts, config maps, etc., everything of our Kubernetes cluster. And that's why we have to run these commands that you will get after you run Kubeadm init command. At the end, you must see these commands, and you can say that it is a symbol that your Kubeadm init command has run successfully. So after that, I will export the kubeconfig, and now we must be able to run Kubernetes commands and kubectl get pods. You can see that there are no resources found in the default namespace. But if I run all namespaces, and now you can see that we have these components of the master node. They are running fine, and it means that our master node or the control plane is up and running. So we also have core DNS, and it will take a little time to run. And after that, we have to install network plugin Flannel, and it is an open source container network interface plugin which creates a virtual network for containers so that the containers can communicate worker nodes and also with the master node. And it is required so that worker nodes do not face any issues while communicating with the master node. So you can say that it is just like a virtual network of the master and the worker nodes. So we have to install this plugin on the master node only. All right, you don't have to install it on the worker nodes, and I will just run it. You can see a new namespace has been created, and a new RBAC account has been created, a config map, and a daemon set. Now if I run kubectl get pods, and luckily everything worked perfectly without any issues. Now you can see every component of our master node is fully functional. But there is something we are forgetting. Now it is saying that you can join any number of worker nodes. We have done this. It is talking about the Flannel plugin. Okay, we have already installed this pod network. We have used this Flannel. All right, and after that, there is one step. We are one step away from joining our worker node with the master node. Now if I run kubectl, kubectl, get kubecontrol. By the way, you can see we have only one master node. So in order to join worker nodes with the master node, make sure that you save the Kubeadm join command, okay? And it contains the token information and the certificate hash. So I have saved it. Make sure that you save it. And now we are logged into the worker node. So I will also change the settings, use system colors and appearance as 14, and I will apply. So this is my worker node. I will restart the session and sudo -i. So I will run apt update. Now I will repeat all these steps that I did on my master node. So first of all, we are going to disable the swap memory should be disabled, and after that apt get update, and I have run already. I will install these prerequisites, and now we are going to install container, and I will just copy and paste these commands. So you have to do is the same way, just copy and paste the commands, and we will have container installed in a couple of moments. All right, and after that apt update and this command. So I will run apt update, and now I will install container. And after that, once it is installed, we will do the same practice. I will create this directory and I will copy the default configuration of container, and now I will just edit my container configuration file, and I will change the value from false to true. Control W, I will search it and true, and I will just save it. And after saving the configuration, we are going to restart container, and our container should be running on our worker node. All right, it is running, so it is not a big deal, and you can easily run these commands to install container. So now after that, we are going to install these components of Kubernetes on our worker node as well. So make sure that you pay attention. There is one last step that we must know in order to avoid any inconvenience. So I will just paste these commands, and these commands are just to update our repository, okay, so that we can install the latest version of these core components of the master node. Now our repository has been updated, so I will run apt update, and after that I will just run this command to install the components of my worker node, and I will also hold the version so that each master and worker node should have the same versions. And running this command, these are some prerequisites, you can say, and I will run this, and after that we will update our system with the configurations. Now I do not have to run this command at all on my worker node. This command should be run, I will mention it here, sorry I forgot. this command should run on the master node only, and we should not run this command on the worker nodes. We just need the components, the services on the worker nodes. And for your information, I have also shared here that just like we did install container, Kubeadm, Kubelet, and Kubecontrol on master node, we have to install these packages on the worker node as well. There is an important point to remember that we don't have to run Kubeadm init, which initializes the Kubernetes cluster on the worker node, because we are going to join our worker node with the master node. So we don't have to initialize Kubeadm on each worker node. We don't have to do this, and it will create a mess. So instead, we have to run Kubeadm join to join the worker node with the master node to create a Kubernetes cluster. And this is actually the general command. And now I told you that we have only Kubecontrol get nodes on the master node. You can see we have only one master node, and when we run this command Kubeadm join, so our worker node will join our master node and it will be a Kubernetes cluster. All right, now let's see. Okay, so it worked like a charm. I was expecting some issues, but there were no issues and everything worked perfectly. Alhamdulillah. And now this node has joined the cluster. So our worker node has joined our master node. So certificate signing request was sent to API server and response was received. Okay, so the kubelet was informed of the new secure connection details. Now I can run Kubecontrol get nodes on the master node or the control plane to see if our worker node has joined it or not. Guys, this is beautiful, by the way. So I will run Kubecontrol get nodes and we should see our worker node here. So the suspense is over. All right, and you can see our worker node is ready and it has joined our master node. So now you saw we had only one master node, and now similarly, if I have 3 worker nodes or 5 or 6 worker nodes or 12, I have to do the same practice and I can join all these worker nodes with the master node, and master node would be responsible to manage all these worker nodes. So guys, you can run these commands. I have practiced and I have run these commands again and again to make sure that you don't face any issues while creating your own Kubernetes cluster. So these, you saw that every command worked like a charm. There were no issues running in any command, and these are optional. You can run Kubecontrol autocomplete so that you get all these commands auto completed, and we can execute the following commands for Kubecontrol autocomplete, and it is recommended for quick learning. So let's try this out as well, and I will run this on the master node. All right, and after that, alias k is equal to Kubecontrol, or sorry, and if I run k, now you will see the magic. Okay, k, and we will have all the Kubecontrol commands. Okay, k get pods, oh sorry, k get pods and k get pods hyphen a. So we have k, the alias of Kubecontrol command. So instead of running Kubecontrol again and again, I can run simple k and it will share all the Kubecontrol commands. Now guys, there is one last thing before we wind up this lecture. You can see I am going to create a deployment and we are going to run our NGINX, simple NGINX web server on our worker node. So first of all, I have to create a deployment. All right, this is my deployment. We are going to just deploy a simple NGINX web server on our worker node. Nano deployment .yaml. Okay, in this, and I will just save it. Kubecontrol or K apply -f deployment, and now my deployment has been created in the default namespace. Okay, kubecontrol get deployment, and it is ready. After that, we have to create a service. A service exposes our application for the external users. Now I will create a service nano web.yaml, and I will paste. You can see this is simple web service running NGINX on this. This is the node port. A node port is actually the service type for external users, and I will just save it. And after that, I will run kubecontrol apply -f web.yaml. Now our service should be created. Now if I run kubecontrol get pods, I should have one pod running NGINX in the default namespace, right? You can see I have this. And if I log in inside the pod, I will run kubecontrol exec -it and the pod name and the command bin bash. I have logged inside the pod, and now I can run curl localhost :80. Okay, our NGINX is running on our pod. You saw that. Now this pod has been created on the worker node. You don't have to confuse. The worker node should have the pods, but we can manage all these pods running on the worker nodes from our master node. So I will just exit, and if this is actually the IP address of worker node, curl if config dot me, and if I run this is the worker node's IP, and if I run the node port, right, where is my node port? I can see this is my node port. By the way, I can check, sorry, I can also see kubecontrol get service svc. Now I can also see the node port here as well. So I will use the worker node. Now this is the IP address of my worker node, and I will use the node port here. Okay, you saw that our NGINX has been deployed on the worker node. This is the IP address of the worker node. Again, if I tell you, this is my worker node 16.16.210.9 and 16.16.210.9, and it is running on this node port. But if you want to run it on port 80, we will have to use NGINX as the reverse proxy. All right, so we can install NGINX on our worker node just like we can do it on a normal machine, on a normal Linux machine. Apt install NGINX, and we will have NGINX. After that, I just have to edit the default configuration file, and I will just paste these contents so that we should not use this port. This is the node port. All right, and I will clean up the file, and I will add my own content, the configuration I mean to say. So you have to change the IP address here. Don't worry, I will share every file so that you can do it on your virtual machines or on your local. So what is the IP address of the worker node? I will get it from here and I will copy it. And what was the node port? So I will get from here and I will copy the node port. And now our NGINX will route the traffic on this port to port 80. Okay, so this is some additional step, and I will just run service nginx restart, and I hope that everything should be good. Now if I remove the port and run, okay, our nginx is now running on port 80. I can run it in a different browser as well to make sure that it is not from cache. So okay, so our nginx web server is running on our worker node on our Kubernetes cluster. So guys, now you can see this is our Kubernetes cluster, Kubecontrol get nodes, and we have one master node and we have one worker node. So that is actually the same practice you have to do to add more worker nodes. Make sure that when you initialize your Kubernetes cluster, you save this Kubeadm join command, okay, so that you can later run it on your all worker nodes. That is actually important. But what if you lose this command? You can run this command as well. You can use it, Kubeadm token create, and it will share the token and the join command again if you run it on the master node. If I run it, okay, you can see I have got the Kubeadm join command. Now I can save it. So don't worry, I will share each and every command and file with you guys so that you can create your own Kubernetes cluster with one master node and with one worker node. Alright guys, that's it for today's lecture. You saw that we created a master node and we had a worker node. Both virtual machines were created on my AWS account. So you have to create 2 virtual machines or 3. That is totally up to you. So the practice is the same. If you have one master node and one worker node, you will learn a lot from this practice as well. So I have one master node and this one worker node in the same VPC, in the same security group and internet, etc., everything, so that their communication, there are no issues and everything should work without any issues. After that, on master node we installed container and we also installed container on the worker nodes, and these commands you can run on both master and worker nodes. And finally, on the master node, we initialized our Kubernetes cluster. This command should run on the master node. And after that, we configured, we set up our worker node. And finally, we joined our worker node with the master node. And also you saw that we deployed a simple NGINX server on our worker node. So that's it for today's lecture. I will watch you in the next lecture where we will cover more Kubecontrol commands. We had already discussed 50 Kubecontrol commands, and you saw that Kubernetes CLI is a must learning tool. You have to learn Kubecontrol commands, each and every command, to create pods, to get deployments, to get services. So I will have a list of more Kubecontrol commands, and we will have around 60 to 70 in total. So make sure that you subscribe DevOps Molvi. We are going to learn more about Kubernetes in our this free Kubernetes course for beginners. Have a good one. Bye.